this video, we're going to examine three types of percent problems. And there's some basic terminology that you should know. Percentage, rate, and base. Percentage is the answer obtained when a percent is taken of a number. Rate is the percent taken of a number. And base is the number of which the percent is being taken. So the first type of problem that we're going to take a look at is simply finding a percent of a number. So this is problem type 1. And to find a percent of a number, you change the percent. And in this case, the percent is 8.25%. And this is referred to here as the rate. To find the percent of a number, the number here is 400. This is considered to be the base. So to find a percent of a number, you change the percent to a decimal. So my percent or my rate is 8.25%. And remember, to change a percent to a decimal, we drop the percent and move the decimal 2 places to the left. So if I move the decimal once, it would be in front of the 8, but I'm going to have to add a 0 in order to move the decimal 2 places to the left. So that's 1, 2. So my rate is 0.0825 as a decimal, times my base, which is 400. Now, some students have some difficulty remembering which one's the rate, which one's the base, and which is the percentage. So simply put, to find a percent of a number, you change the percent to a decimal. My percent is 8.25%, and I'm changing that to a decimal, so simply slide the decimal 2 places to the left, and then you multiply. So that's 0.0825 times 400. Remember, if there's not a whole number involved, then it's customary to put a 0 in front of the decimal. Now, I'm not actually going to do this arithmetic for you because in one of the previous sections, we've learned how to multiply decimal numbers. But if you were to multiply 0.0825 times 400, you would get an answer of 33. And the answer obtained when you take a percent of a number is called the percentage. So the base is 400. The rate, or the percent, is 8.25, and the percentage is the answer that I obtain when a percent is taken of a number. So the percentage here would be 33, but the actual percent or rate is 8.25%. So that's one way we can find a percent of a number. Now, another way is to set up a proportion. In one of the previous sections, we talked about proportions. A proportion is the equality of two ratios. So we're going to solve the same problem, but this time we're going to solve it by setting up a proportion. So a proportion is the equality of two ratios. It's the equality of two ratios. So here I would have to come up with two ratios. Well, one of the ratios is going to come directly from your rate or your percent. Remember, we talked about percent before. We said the percent means hundreds. In fact, I told you that the legend has it that this is the 1 and this is the 2 zeros in the number 100. So if I wanted to express 8.25% as a ratio, since ratios means hundreds, that would be 8.25 over 100, because that's what percent means. It means hundreds. So that's 8.25 over 100 is equal to, and here you're going to have to determine where the only other value that you have, 400, is placed. And 400 goes downstairs, because if I had 100% of this number that I'm working with, I would have 400. So the value that I'm looking for, or the missing value, here goes upstairs in this particular ratio. And we can call that anything we want to. I'll just call it x. And remember, to solve a ratio, you take the cross products. So 100 times x is 100x times 8.25 times 400 is actually 3,300. And then divide both sides by 100. The 100s cancel here. It leaves you with x is equal to, and remember, when you divide a decimal number, and we could say that this is a decimal number, and the whole number, the decimal, is understood to be to the extreme right. When you divide a decimal number by a power of 10, you simply slide the decimal to the left the same number of places that you have zeros in your power of 10. So in 100, I have 2 zeros, so I'm going to slide this decimal 2 places to the left, so I get x is equal to 33, which again in this particular case happens to be your percentage. Either way, you get the same thing. Some students prefer to solve this particular type of percent problem by using the procedure that I've outlined here to the left, the rules, and some students prefer to solve it using a proportion. The advantage of using the rules is, if you learn the rules, then to solve the problem it's pretty straightforward. The advantage of solving using a proportion is you do not have to learn the rules. However, the disadvantage is if you place any one of these numbers in the wrong place, then you're not going to obtain the correct answer. So you've got to know where to place each one of these values, including your unknown, in order to derive the correct answer. So here what we have done is we found a percent of a number. So that's the first type of percent problem that we're going to take a look at. And again, to find a percent of a number, you simply change the percent, or your rate, to a decimal. Change your percent to a decimal, and then you multiply by the base, and that gives you your answer. And again, the author refers this to the percent, or the rate, as the rate, the number of which the percent is being taken as the base, and the answer obtained when a percent is taken as the percentage itself. Again, I'm not going to get too hung up on those terms. The only thing I really care that you know is how to find the percent of a number. So change the percent to a decimal and multiply. Or you can solve it using a proportion. The second type of percent problem we're going to look at is how to find what percent one number is of another. To find what percent one number is of another. So the first thing you need to do is write the relationship as a fraction in the form is over of. So here we have what percent of 16 is 11. So 11 corresponds to is, and 16 corresponds to of. Or as the author indicates, what we're trying to do is find the percent, or the rate, and the rate is equal to the percentage over the base. And remember that the base is the number of which the percent is being taken, and the percentage is the answer obtained when a percent of a number is taken. So if I take a certain percent of 16, which is the base, I get 11, which is the rate. And again, some students have difficulty with the terminology rate, percentage, and base. Here you need to note that the percent is not given. That's what I'm trying to find. So this is just like taking, as we had studied previously, a fraction and converting it to a percent. You go fraction, decimal, percent. So what I'm going to do is write the relationship here when I'm trying to find what percent one number is of another as a fraction in the form is over of. So identify what corresponds to is and what corresponds to of. And that gives you your fractional relationship. But remember, I'm looking for a percent, and a fraction is not a percent. So the next thing I'm going to do is I'm going to take that fraction from step 1, and I'm going to convert that to a decimal number. So remember that your numerator, which in this case is 11, is always your dividend, and your denominator is always the divisor. So in this particular case, this is 11 divided by 16. And remember, we talked about this. The fractional bar is nothing more than a division symbol. So 11 is the dividend, that's the number that's being divided, and 16 is your divisor, that's the number that you're dividing by. So if I were to divide 11 by 16, I would obtain a quotient of 6.875. .6875. And again, I'm not going to do the arithmetic here because we've already discussed how to divide decimal numbers in a previous section. But now I have a decimal number, and I'm looking for a percent or a rate. So the next thing I need to do, step 3, is to convert that decimal number to a percent. So my decimal number is 0.6875, and to convert that to a percent, I move the decimal 2 places to the right. So that would be equivalent to 68.75%. So what I'm doing here is finding a percent of a number. And to find a percent of a number, you write the relationship as a fraction, then you convert that fraction to a decimal, and then you convert that decimal to a percent. So it's just like changing a fraction to a percent. The way you obtain the fractional relationship is you write is over of. Then you divide numerator by denominator and express that fraction from step 1 as a decimal. So here I will divide 11 by 16. Numerator, again, is the dividend, and the denominator is the divisor. The divisor is what you're dividing by. It's 11 divided by 16. And that gives you a decimal number. But a decimal number is not a percent. So change that decimal number to a percent by moving the decimal 2 places to the right, which we've done previously. Still looking at the example, finding out what percent one number is of another. I gave you some rules in the previous example to show you how to find what percent one number is of another by expressing the relationship in the form is over of, obtaining a fraction, changing the fraction to a decimal, and the decimal to a percent. The drawback from learning the various types of rules, as you see, I have a different set of rules to learn for changing a percent or finding a percent of a number, which is different from finding what percent one number is of another. So every time I change types of percent problems, I have to use a different set of rules. However, I can still solve this problem by setting up a proportion. Remember, the proportion is the equality of two ratios, and a ratio is nothing more than a fraction. So I have to come up with two fractions, and one of those fractions will be missing a part. So again, I'm going to start with the relationship is over of, just like I did with the rules, to come up with the first fraction. Now remember, I'm missing a percent. Percent is what I'm trying to find. And percent is equal to something over 100. That's the definition of percent. So I got to find out what that something is. So I can solve this problem by setting up a proportion. Now, one thing that I need to point out here is that type 2 problems are easy to recognize. Finding what percent one number is of another, finding what percent one number is of another, that problem is easy to recognize because percent is not given. That's what you're trying to find. So in these type of problems, the percent or rate is not given. That's what you're trying to find. So I'm going to cross multiply, take the cross products, and that gives me 16x is equal to 11 times 100, which is 1100. And then I'm going to divide each side by 16, as we did when we were solving equations. Now I'm going to divide 1100 by 16. And if I divide 1100 by 16, I get 68.75. So 68.75 over 100, remember hundredths, percent means hundredths, is equal to 68.75%. Same answer that I got above. Here we're examining the third type of percent problem, and that's to find a number when a percent of it is given. I must caution you though, because these types of problems look very similar to the first type of problem that we solved. Here I'm not asking you to find 50% of 230. If I were asking you to find 50% of 230, it would be the same as the first type of problem that I presented. You just simply drop the percent, change the percent to a decimal, and multiply. But I'm not asking you to find 50% of 230. So let's look at the difference between finding a percent of a number and finding a number when a percent of it is given. 230 is 50% of what number? So if I take 50% of some unknown number, I get 230. And what I want to know is, what is that unknown number? If I take 50% of some unknown number, I get 230. What I'm trying to find is that unknown number. So I've given the percentage, which is 230, and I have the rate or the percent, which is 50, and I'm trying to find the base. So if I were going to write that as a formula, it would be the base is equal to the percentage over the rate. And again, I'm not going to get real hung up on these terms because sometimes the students have difficulty understanding the difference between the percentage and the percent, or which is actually the rate. So if you use these rules, then you really do not have to remember these formulas. So the first thing I'm going to do is I'm going to take my percent and I'm going to change it to a decimal number. So my percent is 50%, and if I express that as a decimal number, that's 0.50. And I really don't need this 0 here. Then the second thing I'm going to do is take my given number, which is actually my percentage not my percent, but my percentage. Remember, the percentage is the answer obtained when a percent of a number is taken. If I take 50% of some unknown number, I get 230, so that's the percentage. And I'm going to divide that by the rate, or the percent. So, again, the rate here is what I refer to as the decimal number. So I'm going to divide the given number by the decimal number from step 1. So my decimal number from step 1, in this particular case, is 0.50. So that's 230, that's the given number, or the percentage, divided by the rate, which is actually the decimal number, that's the percent changed to a decimal, that's 0.50. So it's given number divided by the decimal number from step 1. And again, I'm not actually going to show you the computation here, because we have done that before. We have divided a number by a decimal number. But 230 divided by 0.5 is 460. So that's the number that I'm looking for, or in this case, the same as the base. So what does that mean? That means if I take 50% of 460, I get 230, which makes sense because 50% of something is 1/2. 1/2 of 460 is 230. Now remember, I said that you could also solve any of these problems, percent problems, using a proportion. A proportion is the equality of two ratios, and a ratio is a fraction. So I've got to come up with two fractions if I'm going to solve it by a proportion. Now which method you use depends entirely upon you. The advantage of using the rules are, if you remember them, they're straightforward. The disadvantage of using the rules is that each set of rules is different as the type of percent problem changes. So you have 3 sets of rules. The advantage of using a proportion is that there are no rules to remember, but the disadvantage is if you get any of the numbers in the wrong location when you're setting up your proportion, then your answer is not even going to be remotely correct. So again, a proportion is the equality of two ratios. A ratio is a fraction. So I'm going to come up with two fractions. One of those fractions will be missing a part, and when I solve for that missing part, that gives me the answer. One of those fractions comes directly from your percent, 50%. Percent means hundredths, so 50% means 50 over 100. Now I have one other number, that's 230. So I got to decide where the 230 goes in this particular ratio here. 50% is 230, so the 50 and the 230 correspond, and the number that I'm looking for, or the base, goes downstairs. So to solve this particular proportion, I take the cross products. So it gives me 50x is equal to 100 times 230, which is 23,000. Remember, when you multiply a whole number by a power of 10, all you have to do is to attach to the right of that whole number the same number of zeros as you have in your power of 10. So that's 2 zeros, so I add 2 zeros to the 230 here, and that gives me 23,000. Divide both sides by 50, and that gives you x is equal to 460. So you're going to get the same thing either way if you set up your proportion correctly. We're still looking at the 3 types of percent problems, and again, just to review quickly with you, they are finding a percent of a number. To find a percent of a number, you change the percent to a decimal and multiply. To find what percent one number is of another, that's the second type. You write the relationship in the form is over of, which is a fraction. You change the fraction to a decimal and the decimal to a percent. Now these type problems are easy to recognize because the percent is what you're trying to find. The percent is not given. So it should be very easy to recognize these types of problems, and those are the ones where you're finding what percent one number is of another. And the third type problem is to find a number when a percent of it is given. In this case, you change the percent to a decimal and you divide the given number by the decimal number. So here we have a problem. So we're looking at solving story problems. So I need to decide what type of problem this is. Is this finding a percent of a number? Is it finding what percent one number is of another? Or am I finding a number when a percent of it is given? Now, when you first examine this problem, you might be tempted to say that it's this type problem because you do not see a percent. But in further inspection of the problem, you are given a percent. A student scored 84. That means they got 84% of the questions correct. That is what a grade really represents. It represents the percent of the problems that you answered correctly. So here we do have a percent. Percent is given. It's 84. So we can rule out this type of problem here. It's not finding what percent one number is of another. So that leaves us with two possibilities. It's either this or this. Now, if I were finding percent of a number, then I would drop the percent, change the percent to the decimal, and multiply. If I found 84% of 21, that gives me a number less than 21. 100% of 21 would be 21. Well, there cannot be fewer questions on the test than the number that the student actually got correct. So 84% of 21 gives you a number less than 21. And there cannot be fewer number of questions on the test than the number answered correctly. So I know that it is not this one either. So this is actually a problem where we need to find a number when a percent of it is given. So we're finding a number when a percent of it is given. If I use my rules, then what I want to do is change my percent to a decimal number. Percent is the same as rate. So my percent is 84%. And as a decimal number, that's 0.84. The second thing I'm going to do is take my given number and divide it by my decimal number. So my given number is 21. So I'm going to divide that by 0.84. Now, my giving number, if you were looking at the formulas that I gave you before, what I'm trying to do is find the base. 84% of the total number of questions on the test gives you 21. So the number of questions on the test is actually the base. And the base is equal to the percentage, not the percent, but the percentage, divided by the rate. And of course the rate has to be expressed as a decimal number. So the percentage is 21. They got 21 of the problems correct. Percentage is the answer obtained when a percent is taken of a number. So if I take 84% of the total number of questions, I get 21. The percent is, of course, the rate, and what I'm looking for is the base. So the percentage is 21, which is the top number here, divided by the rate, which is 0.84. So this basically is the same as this. So 21 divided by 0.84 gives you 25. There were 25 questions on the test. If I take 84% of 25, I get 21. Again, we're still looking at the three types of percent problems. And they are finding a percent of a number, to find what percent one number is of another, or to find a number when a percent of it is given. Again, here we want to apply the three types of percent problems to story problems. So here is an example of another problem which involves percents. In 2015 regular season, The Carolina Panthers won 15 games and lost 1. What percent of the games did they win? So we have to decide here whether this is a problem which involves finding percent of a number, or is it finding what percent of one number is of another, or am I finding a number when a percent of it is given? Well, the first clue is we want to find the percent. In other words, the percent is not given. So therefore, it is this particular type problem here. We want to find what percent one number is of another. So we want to find or set up a ratio. That's basically what we're doing here, is setting up a ratio. We want to find, as a fraction, the games won to the games played. They won 15 and they lost 16. So if I've expressed this as a fraction. But what I'm looking for is a percent. So this is just like changing a fraction to a percent. So we write the relationship as a fraction, then we change that fraction to a decimal number, and then we change that decimal number to a percent. So here I have a fraction. I want to express that as a decimal number. So I'm going to divide 15 by 16. Remember, the fractional bar is nothing more than a division sign. The numerator is your dividend, and the denominator is your divisor. Divisor is what you're dividing by. So if I divide 15 by 16, and again, I'm not actually going to show you where I compute that, that gives me 0.9375. So this is a decimal number. So now I want to change that decimal number to a percent. So I have 0.9375, and to change the decimal number to a percent, move the decimal 2 places to the right, and that gives you 93.75% of the games. So they almost won 94% of the total games they played. Now in the paper, if you follow sports teams, you'll have a column of wins, losses, and then you'll see something that says PCT. So in this particular case, you would see 15L, and then you see 0.9375. And the way that they determine the winning percentage is they divide the number of games won by the number of games played to get this last column. Now, it's not technically a winning percentage, because it wouldn't be a percent until we basically move the decimal 2 places to the right. But anyway, that's how that's computed. Looking at another story problem involving the 3 types of percent problems, H.H. Gregg is having a friends and family sale. Everyone receives 25% off the regular retail price. So we want to know how much you would pay for an HD TV that normally sells for $420 during the sale. So again, we need to decide what type of problem we have here. Now again, notice that the percent, we do have a percent in here, we do have a rate. The percent is given. So that rules out this particular type problem, because to find what percent one number is of another, the percent is what we're looking for. The percent is not given. Here, the percent is given, 25%, so we have a rate. So that rules out this particular type problem. So it's either this type problem or this type problem. And actually here, what I need to do is find 25% of 420. So it's actually finding a percent of a number. So we need to find a percent of a number. So to find a percent of a number, you take the percent and you express it as a decimal number. So my percent is 25%, and expressed as a decimal number, that would be 0.25. Drop the percent, move the decimal 2 places to the left. And then we multiply. So I multiply 420 times 0.25. Or if you're using the formulas that I gave you earlier, again, I don't want you to get caught up on this particular terminology. What we're looking for here is the percentage, and the percentage is equal to the base times the rate. So my base price is $4.20, and my rate expressed as a decimal is 0.25. So I multiply, and that gives me, and again, I'm not going to actually show you the computation, $105. Now, I found 25% of 420, and that gives me 105. But 105 is not the sale price. That is the discount. That is the discount. I can't buy a $420 TV for 105. If I could, then I would buy every one have and sell them for double that price on eBay and make a good profit. But this is the discount. So to find the sale price is equal to the regular price minus the discount. So the sale price would be equal to $420 minus 105, which would be equal to $315. So that's the amount that you actually pay for the HD TV during the sale. Another way of looking at this same problem is that if you receive a discount of 25%, if you're taking 25% off of the retail price, then that actually means that you're paying 75% of the retail price. If you were paying the full price for the item, you'd be paying 100% of retail. But you're receiving 25% off of retail, so that means you're paying 75% of retail. So another way to think about it is to find 75% of 420, and that will actually give you your sale price without having to determine the discount, which is 25%, and subtracting it from the original price. So again, it's still finding a percent of a number. So I'm going to take my percent and change it to a decimal number. So 75% as a decimal number is equal to 0.75. And to find a percent of a number, I still multiply. So I'm going to multiply 420 times 0.75. And if I do that, that gives me $315, which is actually the sale price. Now, if I wanted to do the same thing using a proportion is the equality of two ratios, and a ratio is a fraction. So I'd have to come up with two fractions, and one of those fractions will be missing a part, and when I solve for the missing part, that gives me my answer. So using this particular notion here, one of my fractions would involve my percent. Percent means 100, so that's 75 over 100. If I were paying full retail price 100% for the item, I'd be paying $420. So here is an example of how I would set up the same problem using a proportion. Taking the cross products, that's 100x, is equal to 75 times 420. So if I multiply 75 times 420, that gives me 31,500. Dividing both sides by 100, that gives me x is equal to $315. That's your sale price. So again, all three of these various types of percent problems can be solved using a proportion. The advantage of using the rules are straightforward. However, the disadvantage of using the rules is that I have a different set of rules for each type problem that I need to learn. The advantage of using a proportion is there are no rules to remember, but the disadvantage is you have to make sure that all your values are in the right location in your proportion, or you will not get the correct answer. The last type of problem that we're going to discuss is how to find the percent of increase or decrease. And this is very similar but not quite the same as finding what percent one number is of another. Because as you see here in my rules, I'm going to start out with a fraction, and then I'm going to take that fraction and express it as a decimal, and then I'm going to convert that decimal to a percent. So those are basically the same steps in determining what percent one number is of another, but the relationship here is a little different in that that fraction is determined by finding the amount of the increase or decrease, whichever the case may be, divided by the original amount. So here I have an example. The North Carolina Department of Justice recorded 18 homicides in the Fayetteville-Cumberland County area during the 2010 year. In 2011, there were 25 homicides. So what is the percent of increase or decrease from 2010 to 2011? So this is not quite the same as finding what percent one number is of another, but very similar. But we first express our relationship as a fraction in the form the amount, and in this case it's going to be increase as we went from 18 to 25. So it's the amount of the increase divided by or over the original amount. Now remember, origin contains the word origin, and origin means in the beginning. So the amount of the increase, and you have to be careful here, the amount of the increase is not 18 and it's not 25. If we went from 18 homicides to 25, we went from 18 homicides to 25, then that's an increase of 7. So the amount of the increase here is 7 over the original amount. In the beginning, there were only 18. So be careful here. The fraction that we're working with is not 18 over 25 as we did when we were trying to find what percent one number is of another. If we want to find the percent of increase or decrease, we're going to use this relationship, the amount of the increase. So we had an increase of 7 homicides from 2010 to 2011 over the original amount, which is 18. So the next thing I have to do is to convert this fraction to a decimal number. So that's 7 divided by 18. Remember that the fractional bar is nothing more than a division symbol. So I'm going to divide 7 by 18 to convert that fraction to a decimal. So 7 divided by 18 gives us actually a repeating decimal, 0.3888888, and 8s continue forever. So the third step now is to convert that decimal number from step 2 to a percent. So I want to go from a decimal to a percent. So that's 0.38888. And to change a decimal number to a percent, what I'm going to do is move the decimal 2 places to the right. So that's approximately equal to, I'm going to round this off to the nearest tenth of a percent. That will give me 38.9%. So the percent of increases in homicides from 2010 to 2011 would be represented by an increase of 38.9%, rounded off to the nearest tenth of a percent. And that's not a statistic that you would want the Chamber of Commerce to print in a brochure trying to lure new residents or businesses to our fair town.